In this video, we're going to go over how to simplify expressions. Let's begin. What is an expression? An expression is a mathematical phrase that contains numbers, variables, and operators like addition and subtraction. So let me give you an example of an expression. You can have something like 1 plus 1. That's an expression. Or 2x plus 5. That's an expression. Or 9 divided by 4 is an expression. 3 can be an expression. 28 plus 1 divided by 4 divided by 5 times 6. All of those can be expressions. Notice an expression does not have an equal sign, so you can't say 1 plus 1 equals 2 because that's an equation. Now, 1 plus 1 is an expression, and so is 2, but when you put an equal sign in it, it becomes an equation. So an expression is just the phrase, and it contains numbers, variables, and operators. An expression will not have an equal sign, like we said, equal. Or you could have just done equal sign like that. An example of an expression would be, how about 1 plus 1? Or 8x plus 5. Or how about 1 over 2 minus 3x? All of those are expressions. Notice, no equal sign. All right, let's talk about the word term. A term is a constant or a variable in an expression. It's a constant or a variable. Terms are separated by pluses and minus signs. So add and subtract signs, I'm just going to put a plus and a minus sign. List all the terms in the expression. In this expression right here, so this is a term. This is an expression. Sorry, this is a term. This is a term. This is a term, and this is a term. And if it's a negative, or if it's got a minus in front of it, the term is technically negative. If it's a positive one, you don't have to put plus 6x or plus 13. We assume it's positive. So 6x is a term. Negative 10y is a term. 13 is a term, and 5z is also a term. I'm going to put a little slash through the z. All right, let's talk about the word coefficient. A coefficient is the number in front of a variable in a term. So remember, variables are like x and y. So the coefficient would be the number in front of it. So the number that it's multiplying with it. So 14 with the 14x, we've got negative 7. Is the coefficient. We've got 10. So you may be wondering why not circle the plus 10? Because we know that 10 is positive. Whereas if you look at this and I only circle the 2, it makes you think that it's a positive 2 when in fact it is a negative 2. So yeah, you gotta circle the coefficients. So my coefficients would be like 14, negative 7, 10, and negative 2. All right. Last term, last vocabulary term, like terms. Like terms. In order for terms to be like terms, they must both have the same base or variable. Variable. So same base or variable, and the same exponent or power. So that's what we're going to focus on in this next little exercise. Label the terms like or unlike. Is it like or is it unlike? Negative 15x and negative 15, are they like or unlike? Remember, like terms have the same variable to the same power. Now, there is a variable right there. It's x. Is there a variable over here? No variable. Therefore, they are not considered like terms. Unlike. I'm going to say un. And you're going to assume like. Let's go ahead and write the whole thing. Unlike. So we basically ignore the coefficients in front, like the 1/4, not important. Negative 9, not important. It's the variable. This is a c, and this is a c. Those two are like terms, which means you can combine them. Like. I guess I can use L and U. I'll do that to save time. All right, let's take a look at this one. It's the x square. And the x squared, that means they are like. The y And the x, y and x are unlike. Yeah. 30 has no variable, and neither does negative 25, so those are considered like terms. 17b and 1 over 17b, those are like terms. 10m and 10m squared, they are both m's, but they are m's to different powers, so they are considered unlike terms. 2.2n and 2.2, there's nothing there, so they are unlike terms. So give an example of a like term for each term in the table. So 14y, what's a like term that goes with 14y? Well, you could say, how about 3y? How about 1/2 y? How about, I don't know, negative 2y? Those would all work. You don't have to write all of them. You just need one of them. And the key is that it needs to have a y. Negative 9x, how about 10x? How about just negative 4x? How about just plain x? All those would work. 15b squared. It's the b square we want to make like, so how about 2b squared? Or 1/2 b squared? Or, that's good. 55, there's no variable that it's being multiplied to, so it's just a number, it's just a constant. So how about the number 1, or the number 0, or the number 10, or the number negative 10? It's all good. All right, negative 23xy, that's a new one. Well, xy is going to be the thing that we need to be alike, so negative 23xy. How about 4xy? How about 1.5xy? Those all work. Negative h, again, it's the h we want to be similar to. So how about 3h, or regular h, or 4h? Yeah. All right, m to the third, 2m to the third power. M to the third power is what we need to match. So how about 4m to the third? How about negative 2m to the third? And finally, 200. 200 is a constant, so 5 would be good. 1 would be good. 1/2 would be good. 0.97 would be good. Those all work. All right. Simplifying expressions. Let's talk about that. We can simplify algebraic expressions by combining the like terms. Oops, I did not draw an I. Like terms. Termies. Terms. There we go. So I can simplify by combining the like terms, but be careful when you are combining terms to check the signs. And when we mean signs, we mean the plus and the minus. The plus and minus signs. That is in front of the term. So remember, an expression is like 3x plus 2 plus 7. Simplifying a term means we are combining the like terms. So 3x is one kind of term, right? And let's see, 2 is a kind of term, and 7 is a kind of term. Now, is 7 similar to 3x? No, it doesn't have an x. Is 7 similar to 2? It is, because they're both constants. Neither of them have x's next to them. So you can actually combine those. Positive 2 and positive 7 equals like positive 9. So 3x plus 9. Oops, I just put 3 times 9. 3x plus 9. Or to give you another example, if I had 2y plus 111x plus 4y minus 3x. Where are my like terms? Well, 2y, is there anything alike 2y? Not the 11x, but the 4y is definitely alike. It's a plus 4y. And the negative 3x, that's an x term. So let's combine those two. 2y, which is positive, and 4y, which is positive. Well, that just equals 6y. And then we've got positive 11 and minus 3x. Those are both x terms. So we can combine them because they're both x terms. So 11 minus 3 is 8. So it would be plus 8x. 6y plus 8x. So that's what we mean by combining like terms. All right, so let's actually combine some like terms. Let's talk about, an example, a real life example. A group of friends went to the movies, and bought the following tickets, which they represent with T. They bought tickets, drinks, and popcorn. So tickets are T, drinks are D, and popcorn is P. So I guess they bought 2 popcorns and a third popcorn and 1, 2, 3 drinks and 1, 2, 3, 4, 5, 6 tickets. So write an expression to represent the purchase. Well, I'm not going to write like 3 popcorns. I'm just going to write 3P. And they also bought, so plus a couple drinks. How many drinks? 3 drinks, 3D. And also 6 tickets, so plus 6T. So 6 tickets, 3 drinks, and 3 popcorns. That's how we write this expression. Once we combine the like terms, the simplified expression would be... Oh, actually, you know what? I just jumped to that. Let me explain. Let's go backwards a little bit because I totally simplified. I should have just said, well, they got 2 popcorns right here. And they also got a drink. And then they got 2 tickets. And they got, so 2 popcorns, a drink, 2 tickets, another drink, so 1D, plus another 2 tickets, plus another popcorn, plus 2 tickets. Oh my goodness, I'm out of room. Plus another drink. So if I combine my like terms, the 2 popcorns plus the 1 popcorn, well, that's 3 popcorns. Let's combine the what other like terms I have. Well, I have 1D plus another 1D plus another 1D. Or I just wrote D that time, I suppose. And that equals 3 drinks. Plus I got, let's see, 2 tickets, another 2 tickets, and another 2 tickets. And that equals 6 tickets. So that is the simplified expression. And yes, that is a number 6, not a BT. All right, let's try using that without an illustration. At 13R, is there anything like R? Yes, there is. This one, and this is a positive 13, and this is a positive 5. That is a 18R. And then the 2N, that's just kind of by itself, plus 2N. Let's take a look at the next one. 1.6W. Anything like the 1.6W? Yes. The negative 1.2W. Anything else? Let's see, not this one, but this one definitely. So 4.7W. And it's a positive. So I have 1.6 minus 1.2 plus 4.7. So many ways I can handle this. How about, I'm going to pretend this is 16. 16 minus 12 is 4, so it's like 0.4. That equals 0.4. And then when I add 4 to 47, I have like 51, so 5.1. That's 5.1W. And then what do I have? So I finished dealing with these guys. All I have left is the 3.5, and it's a positive, so plus 3.5. Let's do the next one. I've got 1/3. Negative 1/3 x. So any other x terms? The 2x. And the that's it. And then with the y's, let's see, I've got 15y and negative 5 2/5 y. Goodness gracious. Fractions, horrible, horrible fractions. So let's go ahead and do the 2x minus 1/3. Well, when I do 2x, I subtract 1/3, or let's just, I know I have an x first. If I take 2 and I subtract 1/3, 2 minus 1/3, something x. What is that right there? I think that's 1 2/3, I believe, because 2 is the same as 6/3. And I subtract 1/3, I end up with 5/3, or 2 1/3. So 2 ways you could have written it: 5/3 or 2 2/3. So 2 2/3. So I've dealt with my x's. Goodness. And now let's deal with my y's. My y's are like 15y minus 5 2/5. My goodness, they are not making this easy on us. 15 minus 5. All right, let's do some subtraction. Well, I'm going to borrow from this. I'm going to have 14, and that gives me 14 and 5 fives. 5 fifths minus 2 fifths is 3 fifths. 14 minus 5 is 9. So, 9 and 3 fifths, y. 9 and 3 fifths, y. And it is positive, so that's my answer. That one's a rough one. Let's go to the next one. We have number 5, which is negative 18.7b. Let's see, any other b terms? We do. We have a 4b. And we also have negative 0.2b. Goodness gracious. So it's basically 4 minus 0.2. So let's do 4.0. And that gives me 8.3. And looks like I have to subtract 18.7b. So I have 3.8, which is positive right now. And I have to subtract 18.7, where I have negative 18.7. So it looks like, basically, let's do this. Negative 18.7. Because I have opposite signs, a positive 3.8 and a negative 18.7, I need to do subtraction. And I know that we're going to take the sign of the bigger number. So our answer is going to ultimately be negative. So 7 minus 8 is, I need to borrow. That's 7, that's 17, that gives us 9. 7 minus 3 is 4. And then I bring down the 1, so negative 14.9. B is our simplified term. Whew. Let's go to the next one. Next one. 1/2 b. Oh, they are not making it easy for me. 1/2 b. 8b. What else? Negative 1b. So this is negative 1b. Let's deal with those first. Let's deal with the 8 and the minus 1. So 8 minus 1 is 7b. And it looks like they want us, this is positive 1/2, so 7 plus 1/2 is 7.5. So 7.5b, and then, or 7.5b if you want to think of it that way. And let's take a look. We have, our other term is negative 9, negative 7, and plus 14. It's only one other type of term, negative 9, negative 7, and plus 14. So negative 9 and negative 7, if I combine those two, I should get negative 16. So negative 16 plus 14, well, I need to subtract. And I take the sign of the bigger number, so I get minus 2. 7.5b minus 2. Next one, we've got negative 1.2k. and positive 0.3k. Let's deal with that. Negative 1.2, positive 0.3 or 0.3. That is a subtraction problem because I have different signs, so borrow from that. I'm left with 0, 12. Seriously, why would I do that? I'm left with 9 or 0.9. So I've got, and it's going to be a negative 0.9k. Because the bigger number was negative. Okay, so I'm done with that. Let's do the next term. I have positive 3.9 and positive 0.5. Sorry, that's not correct. It's a G term. So positive 3.9 and positive 7. The other two are G terms. So 7 plus 3.9, I know that. It's 10. 0.9. And then let's deal with the G terms now. This is minus 1G and plus 0.5G, so 0.5 is positive. And then 1 is larger than that, so negative 1.0 minus 0.5. Well, I'm going to get a negative answer, and it's going to be 0.5, so negative 0.5. G. Technically, the correct answer should be, you should do the letters in or the variables in order, alphabetical order. So A, B, C, F, G, H, I, J, K. So G goes first. So technically, the answer should be if I written it correctly. I'm going to write it up here actually. Negative 0.5g minus 0.9k plus 10.9. And yeah, the constants without variables go last, typically. But this one's correct as well. Nothing wrong with that. Nothing really wrong with it anyways. All right, next, simplify an expression for the perimeter of a rectangle. So simplify this. Perimeter of a rectangle is when you add up all the sides, right? So if the top is 17.4x minus 0.8, well then guess what? The bottom is also that length, 17.4x minus 0.8. And if the right side is 6s, guess what the left side's going to be? You're right, it is 6x. So how do we find perimeter? We add up all the sides. So let's add 17.4x plus another 17.4x. Well, we're adding this, and we're adding this, and then we're adding this, and we're adding that, basically. So let's go ahead and add our like terms. I'm going to do 17.4x, then 17.4x, then 6x, then 6x. So I'm going to add all of that. Plus 6x plus 6x. Well, I know 6x plus 6x is 12x. And 17.4 plus 17.4 is 34.8. So 34.8x plus 12x is 46.8x. All right, now I'm not done because all I did was add my x terms. Now I have to add my non-x terms, my other kind of term, minus 0.8 and minus 0.8. So minus 0.8, minus 0.8. Those are both negative terms, so two negatives combined together will make a bigger negative. So that's going to actually end up with negative 1.6. So my perimeter is 46.8x minus 1.6. Last one, I am going to simplify an expression for the perimeter of this equilateral triangle. Remember, equilateral triangles are have three equal sides. So a couple of different ways I could do this. I could have just added all of these sides up, or I could multiply by 3. Let's just add them up. So 3/4. Actually, I mean, technically, it'd be easier to multiply, but whatever. Whatever. 3/4 plus 3/4 plus 3/4 x. Minus 9 minus 9 minus 9. So let's deal with this first portion. 3/4 plus 3/4 plus 3/4. Oh, good. We have a common denominator. That gives us 12/4. No, not 12/4. Darn it. I wish it was 12/4. It's 9/4. 9/4 x. And then after that, we've got the other side, which is minus 9 minus 9 minus 9. That's three negatives. Combine them together, you get minus 27. All right, let's go ahead and turn this into a regular mixed number, not a fraction greater than 1. So 4 goes into 9 twice, which gives us 2. We're left with 1 left. 1/4 x minus 27. And that is our perimeter. And that is that. Hopefully that made sense. Go ahead and try some problems on